Hello, and a very big welcome to the European spaceport in French Guiana and our live broadcast Road to Space. On the pad, we have Europe's new heavy lift rocket, Ariane 6, getting ready to take to the skies for its third launch, and on board is our passenger, MetOp Second Generation A1, the first in a new series of European weather satellites, which will also improve our predictions of extreme events like storms and better understand climate change. It carries 6 instruments on one satellite, including Sentinel-5, to analyse our atmosphere as part of Europe's Copernicus Earth observation programme. Now, we are about 16 kilometres from that pad, overlooking the Mission Control Centre. Indeed, that's actually our view from the commentary box. I'm Katie Haswell, and joining me is Vincent Baudel, who is our rocket expert from Ariane Space. It's great to have you with us, Vincent.
Yes, hello, Katie, and hello to everyone. So great and exciting to be here tonight in Jupiter for this new YouTube Live.
Now, Vincent and I are going to be with you right through until separation of our satellite, and that's going to be happening in about an hour and a half's time. But we have lots for you between now and then. We'll be discovering our satellite and its 6 missions on board. We'll be finding out about operations across the range, and we'll also be meeting the teams, starting here in Mission Control. We call it the Jupiter Control Centre. There it is on the right-hand side of the screen. Very much the nerve centre of operations, the teams in here inside what we call the fishbowl. It's the glass protecting them, and making all the final decisions in there as well.
Yes, and there will be as well the Ariane 6 launch site. That is a dedicated area designed for launcher final preparation. So it includes, of course, the launch pad, but also the launcher assembly and the integration building.
We'll also be meeting the teams in the Launch Control Centre, or CDL as it's known here at the base, closer to the pad. These are the teams who are responsible for all the operations on the rocket and the pad right up until liftoff. Laser focus concentration in there now.
Yes, and we will discover as well the Quick Look telemetry team. So this team collects the real-time data that the launcher sends, which allows us to continuously analyze the launcher behavior and confirm that it is as expected.
Indeed. Now, let's find out how things are looking for the launch, and who better to tell us than the CEO of Ariane Space, David Cavaioles. David, how are operations progressing?
Well, so tonight we are going to operate Ariane 6, which is a brand new heavy launcher of Europe. So Ariane 6 is now on its launch pad. All the indicators are green, the meteo is okay, and we should be able now to perform the launch in a little bit more than 20 minutes.
Great, that's good to hear. David, tell us a little bit more about our passenger.
For sure. So today our client is EUMETSAT, so the European institution in charge of meteorological satellite. And for EUMETSAT, we launched a very special satellite called MetOp-SG-A1. So this is the first of a new generation of polar orbiting weather satellite. And within this satellite, we have 6 instruments, 6 very innovative instruments. And it's worth noting that one of them is called Sentinel-5, and it's part of the well-known Copernicus program of the European Commission.
Indeed, so a very important satellite, not just for Earth observation, not just for our planet, but for literally for each and every one of us on Earth.
Yeah, absolutely, because this satellite will provide extremely valuable data to increase the accuracy of weather forecasts, but also to allow scientists to better understand climate change, to fight against pollution. So this is really a satellite that will provide a tangible outcome for all the European citizens, and for this reason, at Ariane Space, we are extremely proud to proceed to this launch tonight.
Absolutely. Well, David, thank you very much indeed for keeping us up to date there. David Cavaioles, thank you. Right, now just a little reminder, if you happen to be watching us on YouTube, don't forget you can click on the bell to subscribe and follow our launches. I highly recommend that you do. It's always nice to see what's going on, and we do have an awful lot going on here at the spaceport. 21 minutes and 47 seconds to launch our rocket on the pad there. As David said, we are all green and go for launch. Our satellite's due to lift off in 21 minutes and 33 seconds. What's going to happen after that?
Yes, so tonight the Ariane 6 launch vehicle will lift off toward the north, powered by its main cryogenic engine and its two solid propellant booster. So this will be separated 2 minutes and 15 seconds after launch, followed 1 minute and 17 seconds later by the fairing separation once the launcher has left the Earth's atmosphere. The launcher will continue its ascent up to 7 minutes and 35 seconds when the main stage will have finished its job. So the onboard computer will command the shutdown of the Vulcan engine and the main stage will be separated. A few seconds later, the Vinci upper stage engine will be ignited for the first time and will burn for about 12 minutes, putting the launcher into an intermediate orbit. We will then have a long coasting phase going up around the North Pole and down Eastern Asia until shortly before the hour, when the upper stage will be reignited close to Australia. This second boost, which will last only 47 seconds, will allow to reach the targeted orbit. Then, therefore, MetOp-SG-A1 will be separated. And after that, the upper stage will enter a new coasting phase before a third boost, which will slow it down, followed by stage passivation and leading to a re-entry above the Indian Ocean. And this deorbitation will avoid, of course, leaving any debris in orbit, in space.
Very, very important, of course, to avoid space debris. And once MetOp-SG-A1 is released, it's going to start the process of testing and calibrating before it can start its job. That'll be in about a year's time. And my goodness, what an important job it has. With people across the world coping with increasingly extreme weather events, there's never been a better time to improve the accuracy of our weather forecasts and our climate predictions. And that's exactly what our satellite's going to be doing.
Yes, Europe's weather service, EUMETSAT, is launching its new series of polar orbiting satellites, so the second generation of METOPs. It will consist of 6 satellites built by Airbus Defence and Space, working in pairs with an A-type and a B-type. And today we are launching the first one in the second generation, and it is an A-type. That's why it is called MetOp-SG-A1, that is to say, MetOp Second Generation, A-type, number 1.
And on board, it actually carries 6 instruments, I think 6 different but complementary missions. One of them is Sentinel-5, as David was telling us earlier, which is part of Europe's Copernicus program to monitor our planet. And it's very much our eye in the sky for air quality. And that's important because air pollution contributes to millions of premature deaths every year worldwide. So this is super important. Sentinel-5 is going to track pollutants, greenhouse gases and ozone levels across the entire planet. So let's find out a little bit more now about our satellite, MetOp-SG-A1.
As Ariane 6 lifts off from the Guiana Space Center, it carries more than a satellite. It carries the future of weather and climate forecasting in Europe. On board is MetOp-SG-A1, the latest in Europe's family of polar orbiting meteorological satellites, developed by EUMETSAT in partnership with ESA, the European Commission, CNES, and DLR. Its mission: to provide the data we need to understand the weather today and the climate of tomorrow. Circling the planet 14 times a day, MetOp-SG-A1 scans the atmosphere from pole to pole, collecting billions of high-precision measurements, temperature, humidity, and trace gases.
Temperatures in Europe are rising twice as fast as the global average. This makes Europe the fastest warming continent in the world. Data from the first generation of METOP satellites was a game changer, while data from the second generation, the first of which will be launching tonight, will continue that, ensuring that it is the most important source of space-based observations for numerical weather prediction, covering the period of 12 hours to 10 days out until the 2040s.
Built by Airbus Defence and Space, MetOp-SG-A1 carries a new generation of instruments, hyperspectral sensors and microwave imagers designed to detect even the smallest changes in the atmosphere. It also hosts the Sentinel-5 mission, part of the European Union's Copernicus program. The Copernicus Sentinel-5A is the evolution of the Copernicus Sentinel-5P, currently in orbit. This new satellite will perform atmospheric measurements at a high spatial, spectral and temporal resolution related to air quality, methane emissions, ozone and UV radiation. The new mission, together with the geostationary Sentinel-4 and the upcoming CO2M mission, secure Copernicus as one of the most advanced Earth observation systems in the world when it comes to atmosphere monitoring.
With the launch of the Copernicus Sentinel-5 mission on board an Ariane 6, the European Union cements its position as global leader in the provision of Earth observation data. By orbiting the Earth every 100 minutes, the Copernicus Sentinel-5 instrument will deliver daily global data on air pollutants and other atmospheric trace gases, which will be used by the Copernicus Atmosphere Monitoring Service for value-added information.
MetOp-SG-A1's observations will feed models from numerical weather prediction, enabling them to become more precise and timely. Numerical weather prediction models underlie many aspects of modern life: weather forecasts up to 10 days ahead, climate research, and database policies. Working behind the scenes, the satellite helps protect lives and guide governments in the face of what's ahead. In addition, countries in northern latitudes will also be able to use data from the MetOp-SG satellites to improve nowcasting that is crucial for disaster management and early warnings before extreme weather events.
Extreme weather is one of the main causes of destabilization in the world. One key to mitigate the associated risk is more accurate weather forecasting. The European MetOp program contributes to this forecasting and is set to improve through the second generation, which will see pairs of more advanced spacecraft working in tandem. 6 innovative instruments on MetOp Second Generation 1 will provide a range of continuous high-resolution observation essential for operational weather prediction. This mission demonstrates Europe's excellence in Earth observation. Go, MetOp-SG, go!
Together, Ariane 6 and MetOp-SG-A1 embody Europe's ambition to ensure that space innovation leads to greater resilience on Earth.
And indeed, space technologies do play a huge role in enhancing our everyday here on Earth. But of course, we've got to get them into space, and that's our job today. And to do that, we need a spaceport. And our spaceport here at the European Spaceport it's a big place, isn't it, Vincent?
Yes, the European Spaceport is a very big place, so nearly 700 square meters. So corresponding to 6 times of the surface of inner Paris, to give you an idea.
Yeah, indeed. And we call the whole thing the range, which includes the tracking stations dotted along the flight path. And because everyone's spread out across the range, everyone's got to be looking at the same information. And that's why all eyes are focused at this point before launch on the status panels. You saw them back there in the Mission Control Center. We can see them back there throughout the spaceport. And right now the panels are all green. That's a good sign.
Yeah.
So tell us about the panels then.
Yeah, so the status panel shows the live go, no-go status across the base. So, as you said, all must be green for launch to go ahead. And they show the health of 3 main systems across the base. So, of course, the launcher and its ground system. You can see Ensemble de lancement plus lanceur. There is as well the satellite, of course, MetOp-SG-A1, and a third group dedicated to the range, including the telemetry, the radars, the weather, and, of course, the safety.
And the teams watching over those are in the Launch Control Center. We met them earlier, CDL, as we call it. They deal with everything to do with the rocket and the launch zone. What are they doing right now?
Yes, so the Launch Control Center, so the CDL, is where the Ariane and Ariane Group teams are getting the launch pad and the rocket ready for liftoff. So these are the operations team, and they're sending the various commands to turn the launcher avionics on, to fill the propellant tanks, to pressurize the tanks, and to do all the planned tests to confirm that the launcher is ready for launch. And behind them, behind the glass windows, the engineering teams are monitoring all these operations closely, making sure that all parameters are as expected. So they are following all physical parameters, temperature, pressure, electrical current, and so on. And these teams are working in tandem and in real time with the teams in the Space Code Control Room in Paris, who designed and built the rocket. So they are also monitoring the launch from across the ocean. And the teams communicate with each other constantly, and they monitor operations and take important decisions.
Indeed, and that's good. The more people on the job, the better. Right, now we had the pre-final weather check, if you like, at T-20, everything green there. We've got the final weather check coming up in 40 seconds at T-10. What kind of things do we have to look out for?
Yes, so first we need to monitor the high altitude winds, so between 10 and 20 kilometers. So we need to make sure the wind speed and direction are below a certain limit, not because the launcher could not withstand it, but for safety reason in case of launcher malfunction. And we need also to monitor the risk of lightning during the ascent to avoid being hit by lightning, which could harm the launcher avionic. We monitor storm clouds, and on the ground there is not such a problem because we have 4 lightning masts, as you can see on the screen. So 4 lightning masts to protect the launcher while sitting on the pad.
And we use a weather balloon, don't we?
Yeah. We use weather balloons carrying instruments that send back information on atmospheric temperature, pressure, and humidity. And we use as well sensors around the launch base and along the coast for the wind and for the lightning.
And the weather status panel is green, so that's good news. We go for launch. We've had some very clear skies in the last few days here, so fingers crossed for a very beautiful launch tonight. 9 minutes and 14 seconds to go. Here on the pad, we've got various things we can look at. You mentioned the lightning towers. Have a look at that great big building behind the rocket. It's called the gantry, and it's got various jobs, but the rocket is actually, it was protecting the rocket before the launch, and it's actually built on great big wheels, isn't it? It's rolled back just before launch.
Yes, so the gantry, the mobile gantry, so it is a very huge structure, so 8,200 tons of metallic structure, so it weighs about the same as the Eiffel Tower. So it's built on wheels, and it rolls back just before launch. It travels very slowly along a set of rails at 7 meters per minute. So 90 meters high and 40 meters large, and 120 meters rolled back.
Very big. Now, this was some weeks ago, the operations to prepare the
so the cryogenic stages of the launcher arrived in French Guiana on the brand new cargo ship called Canopée, which is also powered by wind. So they were then transferred to the spaceport, and launcher operation started with the horizontal assembly of the main and upper stage in the launcher assembly building, followed by several verification and checks. Mid-July, the integrated core stage was transferred to the launch zone on an automated guidance vehicle, and once it arrived on the launch pad, it was vertically tilted, lifted up inside the mobile gantry, and accurately positioned on the launch table. And of course, the 2 boosters were then transported to the launch pad, and of course integrated onto the main stage. After that, our passenger, MetOp-SG-A1, arrived in French Guiana in mid-June. The spacecraft container was transferred to the preparation facilities, where it was unloaded in the clean room. Some inspection, checks, and health tests were run. Then the spacecraft was transferred to a special hazardous clean room where it was fueled. The combined up started with the mating of the spacecraft on its fly adapter. The spacecraft stack was then transferred to the final assembly building where it was integrated on the Ariane 6 launch vehicle adapter. And after final cleaning and checks, the two half fairings were positioned around the spacecraft and finally assembled. The satellite and fairing stack was transferred to the launch zone by road, and once arrived on the launch pad, the composite was hoisted inside the mobile gantry and integrated on top of the launcher, an operation completed last Wednesday. And about 9 hours ago, the mobile gantry was rolled back.
Indeed, to reveal our rocket. And, of course, rolling back the gantry marked the beginning of what we call the actual final countdown. There have been lots of operations, haven't there, in these last 9 hours or so. What are the highlights?
Yes, so after the gantry was removed, all the propellant lines were flushed to avoid any leftover humidity in preparation for the cooling of the lines, and then the start of fueling, which started around 6 hours before launch. In parallel, there have been electrical checks and harmings, getting the telemetry and radars ready. And now we are in stable situation, waiting for the start of the automatic synchronized sequence.
And that's coming up in the next 20 seconds. Our range operations manager getting ready to announce it. He's picked up the phone. So the synchronized sequence, the automatic sequence, is normally the last 5 minutes of a countdown. So far, we have not actually received yet a confirmation that that has been triggered. We're looking at green status panels. And we're hoping to hear soon from the range operations manager.
À tous de DDO, séquence finale lanceur passée à H0 moins 5 minutes.
Okay, so we have...
Has he announced the beginning of the sequence?
Yeah.
He has indeed. Okay, so that's good news. The last 5 minutes of the of operations, and lots going on during this time. Lots of very, very detailed operations and very fast timed to the millisecond.
Yes, and all those operations are very precisely timed, combining system checks and pressurization of the cryo tanks, activation of different systems and valves. The control of the operation is gradually being transferred from the ground to the computer on the launcher, and it will be the launcher on board the computer who will actually send the main engine ignition command. The same computer will check the main engine before sending the fueling arms disconnection and booster ignition commands for liftoff. Since we have a fixed launch day today, launch today, without a launch window. If we have a stop for any reason, we will need to postpone the launch.
So we're looking here at our rocket on its pad. Just a couple of thoughts about the ignition sequence. We're going to switch the Vulcan engine on before we switch on the boosters.
Yes, 7 seconds before liftoff, the Vulcan engine is ignited. That allows to check it is running correctly, smoothly, before we ignite the boosters.
And let's just briefly tell people about the cryogenic arms, Vincent. You can't see them here, but actually once we get another shot of the rocket, there we've got a great view of them, those yellow arms.
Yes.
So they're clamping onto the top of the rocket, and they are feeding cryogenic fuel into the top of the rocket, very, very ultra cold.
Yes, so the cryogenic arms, so 13 meters long and 20 tons. huge mechanical arms connected to the launcher to ensure the fueling of the upper stage, with liquid hydrogen and oxygen at extreme temperature going up to minus 250 degrees. And they also enable to maintain a constant pressure in the tanks and the stability of fluid inside the launcher up to the liftoff time.
And feeding the same cryogenic fuel into the bottom of the rocket. You can't see them at the moment, but if we change the shot, we might see the big tanks going in there.
Yes, we do the exact same thing on the main stage, so the lower stage. We have the MANG fuel connection, but this time with massive system called MANG installed on the table, so 10 meter high and 100 tons.
Getting close now to the 1 minute mark.
À tous aux DDO, attention pour moins d'une minute. Top à 0 moins 1 minute.
We are 1 minute to launch. Our very best wishes now to all the teams. Good luck, everyone. Bon voyage. Ariane 6 and MetOp-SG-A1 with Sentinel-5.
À tous de DDO, attention pour décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Top. Allumage de CSR et décollage. La propulsion est nominale. Pilotage calme, paramètres à bord sont normaux. Propulsion nominale. Les paramètres à bord sont normaux, la trajectoire est nominale. La propulsion est nominale. Paramètres à bord sont normaux, passage ultrasonique.
On board the third Ariane 6 rocket. Blazing a trail across the night skies here over the Guiana Space Center, the European spaceport in French Guiana. They have started their journey.
Pilotage calme et passage de la pression dynamique max.
We are hearing that the pressure is calm, everything is going well. And we are looking here at two boosters, Vincent. They're doing all the work right now, aren't they?
Yes. We can see the two boosters, so we are in the booster phase. So the mass of the launcher on the pad, 535 tons, so to lift off, you need more thrust than weight, so we need 900 tons of thrust, and the booster are providing nearly 90%
Début de booster ESR, paramètres à bord normaux.
He's telling us that everything is going
Pilotage
well.
calme.
Everything is normal. Getting close now to... We should see, actually, those boosters being jettisoned on our cameras. We'll see two dots kind of moving away from... We're looking there, I think, at probably the engine on the main stage. There we go. We can see the boosters.
Séparation ESR.
And we have confirmation, and that's what it looks like. The two boosters falling away there.
La propulsion est nominale.
Yeah.
So lucky we've got incredibly clear skies.
Image, yes.
Looking now at the main engine, the Vulcan engine, which is now
Trajectoire nominale.
and he's telling us that everything's normal. Right now, the next thing to be jettisoned will be the fairing. That's the top, the nose
Manœuvre en roulis en cours, tout est nominal.
Everything's fine, and the fairing is protecting our satellites. Actually, we've got a good view of it there on our CGI images, the top of the rocket, the cargo bay, if you like. Our
Les paramètres à bord sont normaux.
Stowed inside there, Vincent. It's got a number of jobs, hasn't it?
Pilotage calme.
Yeah, the fairing on top of the launcher has several jobs. So the first one, as you can imagine, is to protect the satellite on the ground from dust, humidity, and so
Trajectoire
on.
nominale.
And at launch, it is an acoustic protection against a huge vibration generated by the different ignitions.
It's very loud.
Yeah, and during the flight, so right now, it protects the satellites against air friction and the extreme heat as we travel through the dense part of the atmosphere. And now,
we have separation of the fairing. It's been jettisoned, so we don't need that anymore. We're out of the dense part of the atmosphere that you were describing. And look at that. Wow. We can see our satellite for the first time, and it's a big one. It's the gold structure.
Yes, so we can see the MetOp-SG-A1 spacecraft position on top of the launcher. So it is attached to the upper stage with a conical adapter. So MetOp-SG-A1, a big bird of more than 4 tons, positioned on top of the launcher in stowed configuration, of course, for the flight. So in gold color, we can see the multi-layer insulation that covers and protects the spacecraft sensitive elements from thermal radiation. And in gray and black, we can see other parts of the spacecraft like instrument or specific equipment.
Propulsion nominale.
Indeed, he's telling us everything's going well up there in space. And yeah, those instruments, we have 6 different instruments on board. Let's tell you about them. If we go clockwise from the top
Pilotage calme, propulsion nominale.
Everything's going well. Yazi, Next Generation, giving us profiles of temperature and humidity, also giving us information about the gases in the atmosphere.
Yes, and just below, the RO, that is to say, radio occultation, it listens to how the signals from navigation satellite like GPS and Galileo bend through the atmosphere to map temperature, humidity, and pressure.
And then below that, we've got MWS, the microwave sounder. Now that's able to see through clouds, giving us information about temperature and humidity, as well as snow and ice.
Yes, and on the other side, we have the 3MI, which that is a new way of monitoring the tiny particles, the aerosol high in the atmosphere associated with the formation of clouds. And just above, Sentinel-5 that will gather data about our atmosphere and air quality as part of Europe's Copernicus Earth observation program.
Indeed, and right at the top on the top left-hand side is MetImage. It's a visual and infrared imager giving us high-resolution images which are very useful for... He's telling us the propulsion is normal, very useful for looking at the clouds and the land surface. It's also useful for looking at sea ice and the surface of the oceans. So 6 incredibly important instruments all packed on board one satellite bristling with technology. And our satellite MetOp-SG-A1 is a great example of teamwork and European excellence.
Pilotage calme, propulsion nominale.
In observation from space, it was built by a consortium of different industries led by Airbus Defence and Space. Now, a quick word about trajectory. Top right-hand side of your screen, the green line is the planned trajectory, and the white cross is our actual position of our launcher. So, we are burning, Vincent, the main stage. It's that whopping great big tank of fuel in the middle of the rocket.
Yes, we are at the end of the main stage flight. So, the main stage, 33 meter high, a mass of 23 tons, and fueled with 154 tons of cryogenic propellant. Yeah.
And he's just confirmed there that we've switched the main stage off.
Séparation LLPM.
And we have separated it and jettisoned it.
Premier allumage Vinci.
And we have ignition, our first ignition.
Tous les paramètres à bord sont normaux.
Vinci upper stage, and everything is going according to plan. So yes, now we've really gone into the next phase of our flight. The upper stage has taken the baton. Its job is
Orbite atteinte avec section Vulcain nominale, les paramètres à bord sont normaux.
Everything's going fine. Everything's going according to plan. Its job is to deliver its
Pilotage
passenger
calme.
to its required destination in space where we can drop it off. And to do that, it's got the engine on it, which is the Vinci.
Yes, the
engine.
Vinci. So the upper stage is equipped with the Vinci engine. So
Les paramètres à bord sont normaux.
two ignition of the engine will be necessary to reach the separation orbit. So and now we are in the first boost of this upper stage engine for a duration of 700.
Premier allumage APU. Les paramètres à bord sont normaux.
15 seconds, that is to say a little bit less than 12 minutes.
And he's just announced that we've switched on a new thing called the APU, a new device.
Yes, the APU, an innovative new device on the Ariane 6 upper stage. So it performs a number of critical functions,
La propulsion est nominale.
including helping with engine reignition and enhance
Pilotage
finally,
calme, tous les
the
paramètres à bord sont normaux.
versatility of Ariane 6.
Our flight path takes us, as you said earlier in the show, Vincent takes us up over
Trajectoire
the
nominale.
North Pole, heading up towards the Caribbean, and we'll be going past Canada, up over the North Pole, and then we'll be coming back down the other side past Southeast Asia, and we will be separating our satellite over the new Norcia tracking station, which is in southwest Australia. The CVI teams there, the quick look telemetry teams, focusing hard there. Can see Galileo, that was our tracking station.
Pilotage calme.
Tracking us.
Paramètres à bord sont nominaux.
Here at the Guiana Space Center, we're now going into the range
Acquisition de la
of
télémesure par la station de Bermude.
the Bermuda tracking station, so we're checking in there and saying hello to the teams in Bermuda.
Trajectoire nominale, paramètres à bord normaux.
Satellites do all kinds of important jobs. That's why we need rockets.
Changement de régime APU nominal.
We've all at some point looked up at the stars and dreamt of being someplace else. But outer space isn't someplace else anymore. It's here, it's now, and it's essential. But why go? Why do we need rockets? No rocket, no satellite. And without satellites, a whole world goes dark.
Pilotage calme, propulsion nominale, tous les paramètres à bord sont normaux.
Telecommunications, Earth observation. Everything uses space today. Farming, climate monitoring, energy,
Trajectoire
security.
nominale.
Space makes life better here on Earth. Satellites guide tractors, forecast cyclones, monitor air quality, connect remote regions to the internet,
Pilotage
and
calme, propulsion
expand
nominale.
access to education, healthcare, and the economy. Satellites launched by Ariane Space connect the world. Each mission brings our world into sharper focus and more within reach.
Tous les paramètres à bord sont normaux.
For any of this to work, we need a gateway to space, a precise trajectory. That's what Ariane 6 does. It is built to adapt to every mission, from low Earth orbit to deep space, to single payload, dual payload, or ride-share flights. And it all begins
Pilotage calme,
at the
propulsion
Space Center,
nominale.
Europe's spaceport. That's where Ariane 6 takes flight. But launching a satellite isn't just pushing a button. It's a high-precision, high-complexity, tailored mission. That's where Ariane
Trajectoire
Space
nominale,
comes in.
paramètres à bord sont normaux.
Like the conductor of an orchestra, from contract to orbit insertion, Ariane Space adapts to every mission for customers around the world. Governments, space agencies, private companies. And in a world where space has become a strategic domain, Ariane 6 embodies reliability, innovation, and independent access to space. Because satellites launched by Ariane Space watch over our lands, our seas, our world. Space is no longer somewhere far away. It's what connects us here on Earth.
Fin de visibilité de la station de Galio.
Space is closer than ever before. He's just told us that we've gone out of the range of the tracking station of Galio, but we are now in Bermuda's range. So, yeah, it is.
Trajectoire nominale, tous les paramètres à bord sont normaux.
Than ever before, but for this rocket ride, we have to go on a bit of a roller coaster. If you look at the top right-hand side of my screen, you can see the trajectory goes up and it's going to go down a bit.
Yes, we can see the evolution of the altitude versus time, and at the time being, we can observe a decrease of the altitude in order to optimize and maximize the velocity by taking advantage of the gravity. It enables to maximize the energy and able to optimize the conditions at injection.
And so that means that basically we're dropping a little bit in altitude now so we can pick up speed and climb higher and higher later in the flight. Here on a hill outside the spaceport is a very important group of people.
Trajectoire nominale, tous les paramètres à bord sont normaux.
CVI, the quick look telemetry team, here they are. They're really, really concentrating hard at the moment, aren't they?
Yes, so the quick look telemetry team, so located at the Montagne des Pères outside the spaceport. So they're collecting real-time data which the launcher sends. So this includes the status of the engine, trajectory and flight control, and they compare the live data from the rocket to what has been predicted. So this allows them to continuously analyze the launcher behavior and confirm that it is as expected. And of course, they can confirm at the end if the satellite is well separated as planned.
Trajectoire nominale, les paramètres à bord sont normaux.
And the range operations manager is listening on his comms loop. So once they have confirmed the major events, then he calls them out to the rest of us across the range. Now we are 15 minutes into MetOp-SG-A1's journey to space, and lots of experts are going to be eagerly awaiting the data from it. One of those is the European Centre for Medium-Range Weather Forecasts. Now, when your local weather presenter tells you that it's the third hottest July on record, they're usually relying on data from the
Trajectoire nominale, tous les paramètres à bord sont normaux.
The teams there gather information from the satellites and put them into big models. The Copernicus Atmosphere Monitoring Service are particularly looking forward to the data from Sentinel-5 to help them monitor the atmosphere and forecast air quality and climate change. And the director of the Copernicus Atmosphere Monitoring Service is with me now. Dr. Laurence Rouille. Laurence Rouille. Laurence,
good evening.
Thank you very, very much indeed for coming up to the commentary box and swapping seats with Vincent. Laurence, you must be absolutely delighted to see your satellite flying in space.
Yes, so delighted. This is exciting times for all the atmospheric chemistry community.
Trajectoire nominale, tous les paramètres à bord sont normaux.
Very, very exciting times.
And I'm just going to adjust your microphone slightly. There we go.
Reste 3 minutes de poussée Vinci.
Laurence, tell us, how do you use the data from the weather satellites? What do you actually do with it? You put it into models?
Pilotage calme, propulsion
So
nominale.
at ECMWF, the European Centre for Medium-Range Weather Forecast, we develop models that predict weather and meteorological variables, but also because we are the interested entity in charge of the implementation of two Copernicus services on behalf of the European Commission, so the Copernicus Atmosphere Monitoring Service and the Copernicus Climate Service. We also run model to forecast atmospheric composition variable, climate variables, and of course, to run this model, we need computational resources, and at ECMWF we have our own high computing center in Bologna, but we also need data, and Earth observation data are essential to run our models. The more good data we have, the better our models perform.
I'm just going to point out to everybody there that we've picked up the signal now at the Gatineau tracking station. That's on the north-eastern coast of Canada in Quebec. So we're being tracked now by the teams there. So,
Propulsion nominale, tous les paramètres à bord sont normaux.
And everything's going according to plan. Now, how will this new satellite and the data from this new satellite change things for you and your teams?
In fact, this is a wonderful mission because there are, on this satellite, MetOp-SG, there are at least 3 instruments that are very important for our atmospheric chemistry community. Sentinel-5, of course, but also IASI-NG and 3MI. And with those, the data monitored by those instruments, we will be able to get new insights about atmospheric composition. I mean reactive trace gas, aerosols, but also greenhouse gases. And with that, we will be able to forecast air quality, to forecast air pollution episodes, to monitor air pollution episodes. We will also be able to provide a long historical data set of air pollution, for instance, of air quality, to assess the efficiency of the mitigation strategy, because with historical data set we can see whether the mitigation strategies that reduce emissions worked, and we can also assess and verify the quality of emission data, emission inventories that are reported according to the international agreement or according to the European directive, checking the difference between what is observed from Earth, from space, and what is modeled by our systems. So a lot of application.
A lot of applications, and we're getting now close to the moment where we will be switching off the engine, and we have confirmation there, I believe, from the Range Operations Manager. I didn't quite hear, but I think this is certainly the scheduled time for us to be switching off our engine. So that's good news. So that's the next phase of our flight. He's telling us that the propulsion's normal. We've now entered what we call a ballistic phase. That's when we are being powered without the engine, so we're effectively coasting without the engine, and that's going to last for about half an hour, and everything's going jolly well on board. Question for you, Laurence. What does all of this mean to you and me, to us in our everyday lives?
I hope we will improve the quality of our forecast, air pollution forecast, air pollution episodes forecast, to raise awareness in such situations. I could give a few examples. For instance, what we've done over the last weeks, forecasting this ozone episode that impacted the whole of Europe for several weeks. I hope that we'll be able to improve the quality of our forecast, or also monitoring the wildfires or the desert dust events that could impact also air quality in Europe and outside Europe. So with such new data, and combination of those data, I hope we'll be able to really improve the quality, the reliability of our forecast and analysis.
Well, thank you very much. We're all relying on you. Thank you so much for coming and telling us all about that. Very, very important work that you're doing, Laurence Rouy. Thank you.
Thank you, Cathy.
The Sentinel satellites are part of Europe's Earth observation program, Copernicus, with a family of satellites orbiting our Earth, gathering information about different parts of Earth's systems. You can think of them as our planet's eyes, ears, and nose, using advanced sensors to see the forests and the oceans, to listen to changes in the atmosphere and detect the air that we breathe. Copernicus helps us keep our world safer. He's telling us the trajectory is normal, safer, healthier, and better prepared for the future. The Sentinel-4 and 5 satellites are dedicated to monitoring...
Gatineau et perte attendue de la télémesure pour une durée de 32 minutes.
He's just said that we've gone out to the Gatineau tracking station, which was part of the plan, and we now have a coast phase for the next 30 minutes or so. So, yes, the Sentinel-4 and Sentinel-5 satellites are dedicated to monitoring our atmosphere and helping scientists and policymakers tackle climate change and protect public health. So, very, very important satellites. The project manager for Sentinels 4 and 5 at the European Space Agency's Earth Observation Programme is Didier Martin. And Didier, I'm absolutely delighted you've been able to come and join us now and take Laurence's place. We're playing musical chairs here in the commentary box. Didier, thanks for being with us. Tell us about Sentinel-5 for a start. I mean, what is it and why is it important?
Yes, thank you very much, Katie. I'm delighted to be here. Sentinel-5, as we have just heard, we're going to focus on the constituents of our atmosphere, and particularly we're going to look at specific trace gases that live in our atmosphere and that impact actually the quality of the air that we breathe. You have to know that European-wide, it is estimated there's about 350,000 premature deaths every year, and worldwide more than 4 million people die prematurely due to poor air quality. So it is very important, of course. But beyond that, these trace gases, of course, play a tremendous important role in our climate. And with the varying climate that we, of course, all notice these days, I don't think that we need to expand too much on the importance to understand our climate, to model it properly. And for that, we need accurate measurements, which we will be carrying out with Sentinel-5.
Yes, and it's on its way to its destination there, so it can start its job. You must be feeling pretty good about that.
Absolutely. I had, when I woke up this morning, I had really a mix of sets of feelings, but foremost, I would say I feel tremendously proud to be here, but to be part of the Sentinel-5 team. It has been a tremendous team working together for a long time to get this together and to bring this to this point in time today. The launch event, of course, is something that is extremely important in a project. It's a massive milestone, and everyone is happy to see this lift off. Obviously, we're super excited about that. And this closes a major part of the development. But we should not forget, of course, that this opens now a new era. And we are all looking forward now to looking at the massive amounts of data that will be coming down and help us understand our climate and air quality.
Indeed, and you're in charge of both the project manager for both Sentinel-4 and the Sentinel-5 missions, both of those, of course, looking at our atmosphere. But the Sentinel-4 mission was actually launched quite recently, wasn't it, in July?
Indeed.
So what's the difference between 4 and 5, and what is 5 going to add to 4?
Indeed. No, it has been actually just 6 weeks ago that we launched Sentinel-4 on board of the MeteoSat Third Generation sounder mission. Sentinel-5 and Sentinel-4 are actually two sister projects within the Copernicus Earth observation program, and both are dedicated to monitoring the atmosphere, as I was explaining earlier. Sentinel-4 is hosted actually on MTGS, and MTGS is in a so-called geostationary orbit, which means that it is hovering over the equator and looking constantly at the whole of Europe and the northern part of Africa. And with that, Sentinel-4 will be able to look with a rapid repeat cycle every hour, monitor this particular zone on Earth. And this will allow us to monitor the diurnal variations of the concentrations of these gases in the atmosphere. Sentinel-5 being hosted on MetOp Second Generation, which is in a low Earth polar orbit, will actually scan the whole Earth. Every day, 24 hours, we will have the full Earth mapped by Sentinel-5. In addition, Sentinel-5 has some additional equipment on board that allows other trace gases to be monitored as well, like methane, which is a very powerful greenhouse gas, CO, and also measure the profile of ozone throughout the troposphere. And so that there are additional features, let's say, that Sentinel-5 will be able to measure.
Fantastic. Well, listen, thank you very much indeed, Didier, for coming in and telling us about it.
It's been a
Such
pleasure.
important missions. Didier Martin, thank you.
Thank you very much.
So it is now 27 minutes into our launch, and travelling there at an altitude of 163 kilometres above our planet and a speed of 812 kilometres per second. Being powered through space by what remains of the Ariane 6 rocket. This is Europe's latest giant leap in space transportation, promising more flexibility, lower costs, and a big boost for Europe's place in space. And it does mean that Europe can take any kind of satellite to any destination in space, from scientific missions to telecoms satellites and even deep space probes. And at the heart of this ambitious project is Ariane Group, which is the prime contractor, we call it, the company responsible for bringing our rocket from blueprint to launch pad. So I'm very happy now for our third joining into the seat here in the commentary box to introduce you to Philippe Clar, who is the Director of Space Transportation Programs at Ariane Group. Philippe, thank you very much for coming up and chatting to us. Philippe, tell us a little bit more about Ariane 6, her vital statistics, what the important
well, to give you some order of magnitude, Ariane 6 is really the European heavy launcher. To give you some rough numbers, the launcher is 60 meters tall, which corresponds roughly to a 20-story building. So it's quite pretty tall, quite a big baby. And the magnitude, the mass at liftoff is around 500 tons. The combined thrust when you take off of the boosters plus the central core is more than 800 tons. So a big beast taking off and to launch those heavy satellites.
Indeed. And actually, I mean, I've got to say the space world is changing. Lots of different types of satellites now being required to be taken into space. So how have you designed this rocket to adapt to those different requirements, to take different satellites to the different places they need to go?
Really, to fulfill the market needs, there are two versions of Ariane 6. One with two boosters, and this is the A62. This is the version we are using tonight, and one version with four boosters for mission requiring a better performance, a higher performance. One of the main innovations of Ariane 6 to fulfill the market needs, it's upper stage, and right now we are in the phase of the upper stage with the Vinci engine, which is a new engine. That this engine can be restarted a couple times during the flight. And this feature really gives a lot of versatility to the launcher to address many different orbits, depending on the customer needs, what the customer is requesting in terms of orbits. Tonight, we will have three reignition of the engine. And we've just done the first one a couple minutes ago.
And here we are in the coast phase now, going towards the next one. So, Philippe, how do you build this rocket?
Let's meet first. Ariane is really a European project across 13 countries in Europe. And I would like to thank all the partners in Europe. There are more than 600 industry working on the launcher all year long. Those 600 companies representing 13,000 people across Europe working on the program. The integration of the rocket is like a giant industrial puzzle, and we at Ariane Group have to align all the pieces, to fit all the pieces together at the right time. And the main integration part, the upper stage, is taking place in Bremen in Germany. The central core. The integration is taking place in Les Mureaux near Paris, and once those two stages are ready, they are transported by boat here in Kourou using the canopy boat, which is another innovation in the program. The two boosters by themselves are really manufactured and integrated here in Kourou. And before going further, I'd like to say hi to my colleagues in Les Mureaux. We have the technical teams over there supporting the team here in Kourou in case of more difficulties. So
a big shout out to you guys. So what's next for Ariane 6 then, Philippe?
Next for Ariane 6, we're working to an improved version of Ariane 6. It's called Ariane 6 Block 2, with the larger boosters and with an upgraded version for the Vinci engine, which is the engine of the upper stage. And this will provide additional performance for our customer needs in the future. And our rendezvous next year for the first flight of this version.
Well, you heard it here first. Thank you very much indeed, Philippe. We look forward to that. Philippe Clare, thank you.
You're welcome.
Right, so we are now going to take a break and come back to you at 10:30 here in Kourou. That's 3:30 in Europe, Central European time. So see you back here then. Don't be late. That we had earlier as Europe's nearest weather satellite, MetOp Second Generation A1 lifted off from the pad here at the European spaceport on board the third Ariane 6 to lift off from this pad carrying its 6 instruments, including Sentinel-5. And Vincent and I are still here in our commentary box, looking down over mission control and still with you. Great to have you with us, Vincent.
Yes, so we have seen a magnificent liftoff tonight in French Guiana. So 2 minutes and 15 seconds later, the two boosters were separated. There was the fairing separation, revealing our passenger, MetOp-SG-A1, to the space environment, and a bit less than 8 minutes into flight, separation of the main stage, and the first ignition of the upper stage Vinci engine. And the first boost for 12 minutes approximately, then we switch off the engine, and shortly we will switch it on again for the second boost.
Indeed, and the range operations manager there has confirmed that we've gone into the tracking station, the footprint, if you like, of the tracking station of New Norcia, that is in southwest Australia. So there we have that's how it looks up there with the engine switching on, the Vinci engine. And we have that confirmed. The Vinci engine has switched on now for its second burn. The propulsion is normal. Our CGI images showing us exactly what that looks like in space. These are predictions, our images. And piloting is normal. The trajectory is normal, and this is a short boost, Vincent.
Yeah. We were on an elliptical orbit, and we need to synchronize it for satellite release. So we need to provide the additional velocity needed, and this is the job of the Vinci second boost that will last only 47 seconds.
And as you say, an elliptical orbit, which is of course the shape of an oval.
Deuxième extinction Vinci.
And he's confirmed there that we've switched the engine off again. So we've effectively shot off one end of the oval and slingshotted ourselves onto a circular orbit. And that was the aim of the game. And everything is going nominally. So we are launching MetOp-SG-A1 for Europe's weather people, EUMETSAT. It stands for the European Organization for the Exploitation of Meteorological Satellites. And that's what they do. They fly the weather satellites. It's an intergovernmental agency based in Germany, and it operates a family of spacecraft gathering information about the weather, the climate, and the environment. And the MetOp fleet is one of them, and of course MetOp-SG-A1 is the new. It's the first in a new series, and EUMETSAT actually works very closely with other countries, first and foremost with its 30 member states, but also with US, Japan, China, and many others. So very much an international organization. And the Director General is Phil Evans, and he joins me now. Phil, thank you very much indeed for coming into the commentary box. Everything's going really well up there in space. We're getting closer to our drop-off, our delivery, if you like, of your satellite. You must be pretty happy your satellite's on its way.
Very relieved, very excited. I'll feel an awful lot happier in a few minutes when we've got confirmation of separation and signal acquisition. But yeah, fantastic.
Yeah, indeed. So just talk us through the EUMETSAT fleet.
EUMETSAT operates a number of satellites. Our core satellites, if you like, are a geostationary fleet that orbits at about 36,000 kilometres and is stationary over the equator. That's a satellite that's very good for monitoring and predicting short period events, intense storms that can have a devastating impact. The second area of mandatory programs is what we've launched this evening is the low Earth orbit METOP satellites, which support numerical weather prediction out to 10 days. And in addition to that, we operate a number of other satellites, particularly for the European Commission's Copernicus program, mostly marine monitoring satellites, altimeter missions and the like.
So very busy around in your headquarters, no doubt. So what about this satellite, though? I mean, the next generation, this second generation. What's that going to bring?
Well, there's two things. The first thing is continuity from our previous METOP mission, and the previous METOP mission had an immense impact on forecast accuracy, reducing errors by 25%, the biggest contributor to forecast accuracy. So it's continuity of those missions, but importantly, the instruments that we've got on the satellite, many of them are highly innovative, particularly IASI Next Generation, METIMAGE, and of course, as we've heard, the Sentinel-5 mission from the Copernicus program, which will monitor trace gases such as ozone, nitrous oxide, and also aerosols, which will open up a new world of forecasting pollution incidents and events.
I was going to say, how is it actually going to sort of improve weather forecast, this next generation? MetOp-SG-A1 and its brothers and sisters, if you like, in space.
Well, the improvements comes from the enhancements of the satellites. Generally speaking, greater accuracy, greater resolution, more channels, and this will help forecast a wide range of weather events. But we've already heard things like pollution events in Europe have been credited with causing up to 350,000 premature deaths in 2022. Sentinel-5 will help with that. We're seeing other events increasing very hot temperatures again, which caused 60,000 deaths in 2022. And these instruments help us forecast that, which makes society more resilient. We're more able to cope with these events.
And it's a massive, huge team effort, isn't it, right across Europe, creating a programme like this?
I mean, it's easy to. I mean, the technological successes, both of the instruments and the launch today, are miracles and something to be hugely proud of. But none of that would have happened without partnership, without collaboration between organisations like EUMETSAT and ESA and across industry. 110, more than 110 companies were involved with this in 17 countries. And it's that collaboration, that spirit of shared endeavour and a common mission that's really underpinned the success of this mission and the launch today.
Gosh, you must all feel very proud.
Very proud and very tired.
Yes, I can believe that. Listen, Phil, thank you so much for coming to chat to us and telling us all about it. And I'm wishing you now the best of luck as we get closer. We're about a few minutes away now until your satellite will be separated. So, Phil Evans, thank you.
Thank you.
So, let's turn the mic off. There we go. Yes, we are 1 hour, 1 minute and 5 seconds now into our launch. And incidentally, the METOP-SG satellites are the first EUMETSAT satellites designed for controlled re-entry into the Earth's atmosphere at the end of their life. And that's really important because it just shows that EUMETSAT's very much committed to reducing space debris, which of course is a big effort across the world now. So, Vincent, you are back. Let's come back to what's happening now in space on our flight. The upper stage is transporting us through space towards the delivery orbit. He's just announced there that we've had the beginning of an orientation manoeuvre, because although the first part of the flight was all about propulsion and power, this part is all about precision and delicacy, because we really need to deliver the satellite to a very specific orbit. And to do that, we've got to twist and turn and maneuver. So what's actually happening up there?
Yes, so we are using the upper stage, so the new upper stage of the Ariane 6. So big innovation with Ariane 6 is mission flexibility, and the new upper stage is a key element contributing to the Ariane 6 huge versatility, and reignition capability. So it is designed to switch on and off up to 4 times, which enables Ariane 6 to perform any kind of missions, embarking one or several payloads to be injected on different orbits. Single launch as tonight for MetOp-SG-A1, dual launch, multi-missions with rideshare or constellations.
So it's a very versatile piece of kit, can take our passengers wherever they need to go, and even a number of passengers, as you say, there at the same time. So let's talk about what's actually happening now, Vincent. We're going through the orientation maneuvers, aren't we?
Yeah, exactly. So on the separation orbit, and before the separation of the spacecraft, the launcher is slowly oriented according to the satellite requirements. So a tilting is done smoothly, and once the launcher is oriented in the correct orientation, the spacecraft separation is ordered by the upper stage.
How does he says everything's going normally? How does it work? How does the upper stage actually eject the satellite into space?
Yeah, so the spacecraft is mated on the upper stage and the adapter by means of a clamber, a sort of mechanical belt, so that maintains and secures the spacecraft on top of the launcher. This clamber is released. This mechanical belt is released and opened by a pyro activation device, and then the spacecraft is smoothly separated by a simple system, relaxation, of specific springs.
So we're actually going to ping it into space with some springs, a bit like a jack-in-a-box, except the jack usually stays in the box, and our satellite's actually going to move away from the box. Coming up now on separation of our satellite in about 10 seconds.
Séparation MetOp-SG-A1.
And we have confirmation. Yeah. Great news. We are looking at some very happy faces.
L'orbite à la séparation MetOp-SG-A1 est nominale. Nous restons en attente des informations du client sur la télémesure satellite.
All the mission control rooms, in the CDL launch control room and in the mission
Début de la manœuvre
control
d'orientation pour le
center.
boost d'éloignement.
And we're going to still going
L'acquisition de la
various...
télémesure satellite est confirmée. Les paramètres satellites sont nominaux.
And it would appear that we've also received
very good news. So we have separation now, so we can see all the teams can relax a little bit now.
And I think I've understood as well that we may have had an acquisition of signal from the satellite. Yeah. I believe that's what I heard. So if that's the case, then that's very, very good news. That means we've called home. So, well, that's wonderful news. Let's go back now.
Les paramètres à bord sont normaux. La manœuvre d'orientation après séparation se poursuit.
Let's go back now to the flight desk and to the CEO of Ariane Space, David Cavalloles. David, you must be absolutely delighted. That was a fantastic mission. Everything went like clockwork.
Yeah, no, absolutely, Katie. This is an absolute success. We are relieved. We are delighted. This spacecraft was so important for science, so important for our citizens. It's really great. And today, my first thoughts go to our client, EUMETSAT, but also the CNES, the ESA, the European Commission, the DLR, Airbus, and many other partners. I simply want to say thank you. Thank you for your trust. This is really, really great, and we are proud to work with you.
Now, what does this launch mean for Ariane space, David?
Well, for us, this is a key milestone because, as you know, we are still at the beginning of the Ariane 6 story. This is the second flight of Ariane 6 operated by Ariane Space. This is the second success. So this is really a good way to start the exploitation of this launcher. And now our challenge is to continue the ramp up. In the near future, we'll be launching more and more with a new launch to come quite in a short time frame. But today the priority is simply to celebrate, and I would like to say a big thank you and a big congratulations to all the teams involved. This is a fantastic achievement. Congratulations and thank you.
Indeed, congratulations indeed. David Cavallolis, thank you very much indeed. So let's now hear from the Lithuanian commissioner who is responsible for defense and space, Andrius Kubilius.
Dear colleagues at the European Spaceport, space enthusiasts, good morning or good evening, wherever you are. This Ariane 6 launch is a big success for Europe. An European rocket with an European satellite on a mission to serve humanity, to monitor air quality and air pollution, to make life on Earth better from space. With cutting-edge technology, the Copernicus Sentinel-5 instrument, as part of the MetOp weather satellite, put in space by Ariane 6, to deliver state-of-the-art data on our atmosphere, showing that Europe is a global leader, both in space and to counter climate change. So I thank the incredibly talented people at the European Spaceport and everyone else who made this possible, because launching a satellite is never a solo mission. ESA, EUMETSAT, Ariane Space, and my dedicated teams at the European Commission. Thank you. More is to come. In space, the sky is never the limit. We have ambitious plans for space.
Fin de visibilité par la station de Nunancia et perte de la télémesure attendue pour une durée de 29 minutes.
Indeed. And it's a very, very important day today, a good day for everybody. Very happy faces there in the mission control room. For some people now the job is over, and for others, of course, the job is just beginning, because we have the spacecraft controllers now taking on their satellite and taking it through its early phases of its launch and early operations. Let's go down now to the mission control room in front of the fishbowl and talk to some of the key players here from the various organizations involved in today's launch. Hello again, Phil Evans, Director General of EUMETSAT, also to Simonetta Kelly, who is the Director of Earth Observation Programs at ESA, and Rüdiger Hartwig, who is the Head of Institutional and German Programs at Airbus Defence and Space, who built our satellite. Starting with you, Phil. Well, this is a good day. You must be very pleased. You said earlier you were going to be happy once the satellite was separated, and now we have that good news.
Indeed. Well, partners, colleagues, friends, this has just been a fantastic evening. It's difficult to put into words the significance of the success so far. I mean, firstly, congratulations to Ariane Space and great news for the Ariane 6 program. But this is not just a launch, it's a huge leap forward for the meteorological world with the launch of this satellite. A satellite, as we've heard, that's full of innovations that will have a concrete impact on our societies, the people who live in it, will help protect people's lives, will protect livelihoods. It's such a significant event. And the success this evening is a testament to hundreds of technicians, engineers, scientists, project managers who have worked together with a common mission, a common spirit to achieve the launch of this amazing satellite. For EUMETSAT and others, the work will continue overnight and into the future as we test and commission the satellite before going into formal operations. And for us at EUMETSAT, this is the start of a new chapter that will benefit societies in Europe and around the world. A fantastic evening, and congratulations to everyone who's played a role in this.
And Simonetta Kelly, Director of Earth Observation Programmes at the European Space Agency. Simonetta, this is a very important day, isn't it, for you folk at the European Space Agency?
It's a fabulous day for Europe, for everybody, for all the partners who have contributed to this fantastic mission. Today, it's collaboration with EUMETSAT, with the Commission, who's virtually with us, of course, with the industry, with the scientists, with the user communities. We have a new satellite, a new generation, MetOp Second Generation, together with EUMETSAT, testimonying the collaboration that we have since decades together. It's innovation in terms of instruments, 6 instruments on board. It's also collaboration with member states. We have instruments from the French Space Agency, CNES, the Next Generation. We have an instrument from German Space Agency, MET-IMAGE. And also, last but not least, we have an instrument in the collaboration with the European Commission, Sentinel-5. All of this will allow us to improve weather prediction, to better work on nowcasting, to better manage our extreme weather events, which are increasing, unfortunately, we hear from EUMETSAT colleagues, and also to better understand the air quality, the air that we breathe every day. So really a mission which is relevant for all citizens. Here, big thank you to everybody who has contributed, but in particular to the project teams. I'd like to pay a special thank you to the project team in ESA, of course, of MetOp-SG, the project team also of Sentinel-5 at ESA, with the 2 project leaders, but also to industry. I'm here next to Airbus, and in fact, Airbus France has been the project manager for all the MetOp-SG with over 110 companies all over the world, and in Europe in particular, and Canada. And on Copernicus Sentinel-5, Airbus Germany has been the leading actor at industrial level with over 50 companies. You see and you understand thousands of people have contributed to prepare this project. The last 11 years of work of people, of teams, and today a little bit an apocal, an EPC moment, as you said this morning, Phil. It's a theater moment, but it's an important one. We look forward the next steps. We look forward the next 5 satellites, and also a great, great big thank you to Ariane, to Ariane 6, to the success 3rd launch, and many more in the future for all of us and Earth observation in particular. So thanks a lot, and really looking forward to the next steps.
And as Simonetta said there, Rudiger Hartwig, it has been an incredible team effort, hasn't it, across the board?
Oh yes, absolutely. We are extremely relieved now. It's more than a 10-year journey on Earth to develop, design and build the spacecraft. And now, thanks to the fantastic job of Ariane Space, we are in orbit, now starting the LEOP phase, which is another couple of months of work. But the moment where you have no control is sitting on the rocket and being lifted into orbit is over. And as I said, we're super, super relieved. And looking forward now to a very good mission where the instruments can demonstrate their performance. And at the same time, this is already the outlook, next year we will have MetOp-B, the sister satellite following, which will be another tremendous effort. And we really hope it will go as well as we have seen this time. Thank you very much, Ariane.
Thank you very much indeed to you. And yes, we look forward to that launch next year, which it will be fantastic and very important. Thank you, ladies and gentlemen. Now, a good day. A good day for Ariane 6, a good day for MetOp-SG-A1, a good day for Europe, a good day for European space, a good day for the world. It's been a fantastic launch. We're going to say goodbye now, but I would like to say thank you very much to you, Vincent, for being with us.
Yes, thank you, Katie. Thank you to our YouTube followers for joining us tonight. So, bon voyage. Thank you, Katie, and thank you to our YouTube followers for joining us tonight. And bon voyage MetOp-SG-A1, bon voyage Sentinel-5, and a very big up, yes, to my colleagues in Ariane Space, in Ariane Group, and all the team involved tonight.
Yeah, absolutely. Big shout out, big up. Goodbye, everybody. We will be back here again for the next launch, so do join us then. But until then, from me, Katie Haswell.
And me, Vincent Baudel.
Goodbye.
Bye.